shift from the parent function. It's crazy to me that I still have people asking me what's a parent function. A parent function, you guys, is a non-shifted function. Every single function has a parent function. A parent function of x squared is x squared, right? A shift just has shifts with x squared. The parent function of a square root function is the square root of x, the absolute value, the absolute value of x. Every type of function has a parent function, non-shifted. So first of all, looking at this one, it says describe the shift from the parent function. Looking at this, isn't it exponential? Isn't x up in the exponent? So it's exponential. So now let's look at the shift. Guys, shifting works the same for all functions. So anything added with x is your shift left and right. So tell me, what's my shift?
Right 2.
We're going to right 2. And then what? Up 1. Okay, so you guys just said that those were our shifts, which is true. So then if I asked you what's the parent function, wouldn't it be the same function without the shifts? So don't make it harder than it is. So you're saying that minus 2 is a shift, and that plus 1 was a shift. Look at it. What's the parent function? 3 raised to the x. Wouldn't that be an exponential with no shifts for this function?
I thought the parent function would just be the x.
That would be a y. Think about it. This is exponentials. Exponentials have the form a times b raised to the x, right? So there's a million different types of exponentials. But our a value would be our stretch and compression, right? Everybody? Isn't that for all functions? And then if there's a negative in front of a, that's a reflection over x. B to the x. That's what makes it exponential. So if we didn't have our b value, we would have no exponential function. So that b value has to be there. Does that make sense, Braylon?
Yeah.
Okay. Questions on that? So that's the parent function. I just wrote that to get you guys seeing it. Okay, next one. What is the shift from the parent function? What is the shift from the parent function? So first of all, you'd say to yourself, well, what kind of function am I looking at? Once again, it's exponential. That x is up in the exponent. Exponentials have the form a times b raised to the x. So let's look at this. Where's my shift? Right here. Left 1, right? And then is there anything up and down shifted? Nope. But don't we have an a value in front?
Yes.
And that negative does what to our function?
Flip it upside down.
Reflects it. Good. Flips upside down. It's a reflection. The negative, it does not have to do with the stretch or compression. A reflection over x-axis. And now my a value is greater than 1, isn't it? It's 2. It's 2 larger than 1. So if it's larger than 1, it's called a stretch, right? So it's a stretch of 2. So there was 3 transformations. So guys, the parent function of this one, the parent function, if I was going to write it out, would have just been y is equal to 3 raised to the x. The base still had to be there, right? Questions? This doesn't have a stretch, it doesn't have a compression, doesn't have any shifts left or right, or up and down. Okay, next one. Hey, this one should, like I said, slap you in the face. We've done it so many times. We have y is equal to the square root of 16x minus 32 plus 4. It says determine the shift from the parent function. It even gave you a hint. In the instructions, it says rewrite it, so that you can determine the shift. So you should say to yourself, I know there's something not right about this. Well, we've seen this 20 million times. Isn't there a 16 in front of x? So wouldn't we want to fix that? Okay, so we want to fix that. So we say to ourselves, we're going to take that 16 and factor it out. Now when you factor it, can you just pull it out of x? No, if you factor something, it's got to come out of each term. There's 2 terms right there. Now does the 16 come out of the radical? No, we're focusing under here right now and we're just rewriting it. It's still underneath the square root. Does everybody understand? It's still under the square root. So we're factoring out. We still have a square root. We're factoring out a 16 underneath the radical. Now we're going to divide each term by 16. Both of them have to be divided by 16. Now, careful. 16 over 16 is 1. That leaves me with the x. Negative 32 divided by 16. Negative 2. Aren't they both still under the square root? Okay. So then we still have our plus 4 on the outside. Now let's think about it. Because they're multiplication, and only because they're multiplication, we can split it up and say We know this is the square root of 16 times the square root of x minus 2. Then we still have our plus 4. What's the square root of 16? So we have 4 times the square root of x minus 2 plus 4. And now isn't that all pretty? So now we can determine the shift from the parent function. Guys, the parent function would be the most basic non-shifted function. It's a square root function. A parent function would be y equals the square root of x for this one, right? So let's determine the shifts in words. A lot of you got like halfway and then you didn't read the instructions. It says, and determine the shifts, or determine or describe the graph, whatever. So it's going right 2 and up 4 and a stretch. Isn't 4 greater than 1? Stretch of 4. I mean, we've done that problem like 25, and now we've done it 26 million times. So let's hope the 27th millionth time we'll get it right. Questions? Am I not making sense? I'm dead serious, like I don't understand what we don't get about it. Okay. Did you internalize it this time? It's in there. Okay. 0% of you got this one right. Literally, 0% of you. And it's one of the easier ones. So let's go through it. Write a piecewise function that represents the following. A piecewise function has its one function that contains multiple pieces of different functions, right? Everybody? Let's look. Isn't this a piece of the function? Isn't this a downward facing line? And it goes till it hits the x value -6, right? Then our new line starts. We have this straight line right here with no slope. And that line is between the x values of -6. This function is between -6 and 2. And then it stops and a new function starts. And we have this upward facing line for starting at 2. So we say we have 3 pieces to our function. So let's go ahead and start it off. The first piece is what we're going to focus on. We're going to focus on this piece. So let's look at this piece and we're going to write the equation. Isn't it a line?
Yes.
Lines have the form y equals mx plus b. M is the slope, b is where it crosses the y-axis. So let's figure out the slope. Down 1 over 1, down 1 over 1, down 1 over 1, right? So it's a -1 over 1, which is -1, right? So -1x, right? Isn't that our slope? And then our b value is where it crosses the y-axis. Well, you're going to say it doesn't. But if we did continue the line by doing the same slope, down 1 over 1, 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 wouldn't it cross at -4, right? So it'll be -x minus 4. Now I'm going to write out the restrictions. Isn't this the function for this function? Isn't this the piece for x values below -6? Isn't it? The x for this is the function for x values less than -6. We're done with that piece. It was that easy. Let's go on to the second piece. It's between, so it's this straight line, right? With no slope. So doesn't it cross the y-axis at 2? And there's no slope, so that's 0x. So that's y is equal to 2. So we have a 2. Now that's our function between -6 and 2, right? So we're going to say it's between -6 and 2. It's x values between that. Now think about it. Isn't it the x value is greater than -6? It eats the bigger thing, so shouldn't it be eating x? Larger? So, and then we have to close off our equal to sign because there's not an open circle right there. So we didn't include -6 on this first function. We had an open circle, but now we closed it off. Now think about it. Isn't it the x values lower than 2? Below 2.
Yes.
So it should be less than or equal to 2.
What about the y value? Where is that?
We don't put y values in for piecewise. We're restricting our domain.
But you did on the first one, the green one. You put
Y equals mx plus b. There's not a y in any of this. I didn't put the y equals. We're just putting the function part in.
about the y-axis -4.
Because there is a y-intercept of 4, I mean of 2. So we went up, we did plus 2. There was 0 slope. So we had 0x plus 2, which is 0 times x is 0.
Yeah, but why is it just a 2? Why isn't it like an x?
Because that would be a slope. There's a 0 slope. This was 0x plus 2, right? Didn't it cross at 2? Straight line at 2. Was there a slope? 0. 0x plus 2 is just 2. What's 0 times x is 0? What's 0 plus 2? 2. That's how we write straight lines. Y equals 2. Isn't that a straight line? Y equals 2, Braylon. Doesn't y always equal 2 on that line? X is changing, but y is the same. Okay. So moving on to the next one. Last one. We have this last function. I'll go with this color. So it starts here, and it's a straight line upwards, an upward facing line. Let's figure out our slope. Are we going up 2 over 1? Up 2 over 1, up 2 over 1. So that's 2 over 1x. That's just 2x. Now let's figure out where it crosses the y-axis if it did. You've got to continue the slope in the same fashion. Don't we go down 2 over 1? Down 2 over 1. It's crossing at negative 2. And that was for x values greater than 2. We already have the equals. I'm done. Questions? Okay. Okay, these are just going to help you with the stage review problems for today, because you're going to do 2 more pages on your stage review packet when you finish quiz correction. So maybe, I don't care if you don't write these down as long as you're paying attention to help you. So look up here. It says, could the following side lengths make a triangle? So remember, the rule is to make a perfect triangle where all the vertices match up perfectly, the sum of any 2 sides has to be larger than the third side. The sum of any 2 sides has to be larger than the third side, or this will happen. You'll have a short little leg and a long one, and then if this one isn't long enough, you see how we can't connect it? Right? And if we did take and connect it, let's say we scooted it in, wouldn't that look like this? Which is not a perfect triangle. Do you all understand that? So that's why the rule comes into play. The sum of any 2 sides has to be larger than the third side. So let's look at A. Could we make a triangle out of these sides? 3, 2, and 7. No, because 3 plus 2 is 6. 5, right? 5, which is less than 7. We cannot make a triangle out of those. So look at B. Could we make a triangle out of this?
Yes.
3 plus 5 is 8, right?
Yeah.
8 is larger than 7. We're good. The sum needs to be larger than the third side. What about 5 plus 7? Is that larger than 3?
Yes.
Yes. What about 7 and 3? If you add those up, is it larger than 5? Yes. So you get why we can make the sum of any 2 sides larger than the third side. So we can make a triangle out of those lengths.
Wait, so do you add just 3 and 5 and see if it's bigger than 7?
Yeah, you would always definitely add the smallest 2 sides to make sure it's larger than the third side. You would try all of them, the sum of any 2. So that's why we did 3 and 5, which is 8, which is larger than 7. Then we tried 5 and 7. Isn't that larger than 3?
Mm-hmm.
Then we tried 7 and 3. Isn't that sum larger than 5? The sum of any 2 sides has to be larger than 3. So what about this one? 3 plus 4 is 7 larger than 7? No, therefore we cannot make a triangle out of those. Questions? Okay. So it says, what is the smallest angle? So remember, triangles or any figure really, but triangles in specific, they have angles that correspond to the side across from them, right?
Yes.
So is an angle A across from side A? Yeah? And angle C is across from side C. So isn't this side C? And angle B is across from side B. So it says, what is the smallest angle?
A.
A. How'd you know?
Because 10's the smallest side.
10's the smallest side. We don't know what that angle is, but we know it has to be the smallest angle, right? Does everybody understand that? Okay, so we'd say angle A. Okay?
That couldn't be a real triangle, could it?
The sum of any 2, yeah, that's true. That wasn't a very good example. This one couldn't be a real triangle because 20 plus 10 is 30. So definitely not the best picture. Maybe I'll need to make sure to change that for 5th hour. Thanks for noticing. Okay, next one. Is angle A or angle C larger? So looking at this picture, is angle A or angle C larger? Tell me, what do you think?
C.
C. How do you know that angle C is larger? C is across from 11. which is larger than 10, which is across from A. So angle C would be larger, right? Everybody get that? Okay. Now this one, you're going to see lots like this. Get them right today on your Sage Review packet. So pay attention because this one is a little bit different at first. It says, what is the possible value of X? So first of all, we have a statement, right? Anytime we have something and we need to solve for X, we have to set up a true statement to solve for X. So let's look at these two triangles here. So we know this is 25 degrees and it's across from side 10, right? And we know this is the angle measure of this triangle and it's across from 8. So everybody pay attention so that this can make sense to you. What's going to be larger, 25 degrees or this angle?
25.
25 is going to be larger. Isn't 10 larger than 8?
Yes.
So won't this angle have to be smaller than 25 degrees? So wouldn't a true statement so far be 2x plus 55 has to be less than, that whole angle has to be less than 25. Don't say x is less than 25. That angle's not x. The angle is less than 25 degrees, right? Okay, now also, don't we know that an angle measurement has to be larger than 0? We won't have a negative angle, right? We won't have a 0 angle or it won't make a triangle. So don't we know as long as it's larger than 0, it's okay? So won't the angle also have to be larger than 0? And now let's solve for x to give us the value to make that angle true. So let's solve for x algebraically. This one doesn't come out very pretty. So we're just solving for x. So if we do something, this is just like a fancy equal sign. So we'll subtract 55 from both sides of the equation.
You have to put that 0 there?
Yes. It's not that hard. If you want to do it separately, doesn't that angle have to be larger than 2x? Doesn't that angle have to be larger than 0? And doesn't that angle have to be less than 25? Solve for x in each case.
Why is it larger?
Can you make a triangle with no angle?
So could you put an over there?
We're solving for x now. That will give us when that value is 0.
Isn't it with one of these?
Isn't that a true statement? Guys, you're thinking wrongly about this. Isn't this angle has to be not x. This angle has to be larger than 0, right? So I said that. That angle has to be larger than 0. That was a 55. I wrote 55. Isn't that true? Then also we know that angle has to be less than 25. So I just put it together so that I could just solve once. So we subtract 55 from both sides. So we have negative 55 is less than 2x, which is less than negative 30, right? If we solve for them individually, we'd get the same thing. So then we would divide by 2, divide by 2, divide by 2. So we know that our x value has to be, what is negative 55 divided by 2? Negative 27.5 is less than x, is less than, negative 15. So x has to be between this value and this value. That's not the angle. So don't say, we can't have a negative angle. Was our angle x? No, our angle was that, 2x plus 55. So let's all look at why this makes sense. Let's all plug it into our calculator. The angle of that piece has to be, x would have to be larger than negative 27.5. Let's plug in negative 27.5. So we have 2 times negative 27.5 plus 55. You get 0. So does everybody understand why x has to be greater than that? Because then it will make it larger than 0. And then also if we plug in negative 15, let's plug in 2 times negative 15 plus 55, we get 25. Doesn't it have to be less than 25 degrees? Yes. So that's why our x is bouncing between these two values.
So we didn't even find the real answer.
We did. You're right, because it could be many answers, right? As long as it's between, the only thing we know is it has to be between that and that. Doesn't that angle have to be between 0 to 25 degrees? Thank you. Any other questions? Okay, so you're gonna do